Sometimes you see the notation of this. Find the derivative of this with respect to x. Chain rule, why? Because that's not just x in the middle. Sorry, inside the parentheses. So I'm just going to use the power rule. Multiply and subtract. So this is 2. Whatever's in parentheses remains unchanged to the 1. Now the chain rule says take whatever's in parentheses and tag on its derivative, which of course is cosine x. So this gives us 2 sine x cosine x. If I had given you originally that the original equation was sine squared x, you can convert it to this and then take its derivative. I'm just reminding you, sine x, the whole thing squared, is usually written like that. Contrast what we just did with a new problem like this. Now, I'll do this out officially here. Let's make this an easier problem. That's not just x, so let u equal x squared. So our new problem becomes, let's say this originally said y equals this, and we're asked to find the derivative. So our easier problem becomes y equals sine of u, if I replace u for x squared. So if u is written in terms of y, or y is written in terms of u rather, dy du is the derivative of sine u is cosine of u. If u is written in terms of x, then the derivative is du dx. Of course, that's 2x to the first power. So dy dx is equal to dy du times du dx. So dy dx, which is what we're after, is equal to dy du, which is cosine of u, times du dx, which is 2x. Now, what was u here? Well, we let u equal x squared. Now, I know that there's a temptation to make this cosine of 2x to the third, but we take cosine of this angle and we want to leave that unchanged. That remains unchanged, I should say. 2x times cosine of x squared. So our angle remains unchanged. And that's our derivative. More quickly, I say y prime is equal to derivative of sine is cosine of whatever, and we tag on the derivative of whatever's in parentheses. If this is x squared, I'm going to say this is 2x. So 2x cosine of x squared is our y prime derivative. Here's our rule. Remember, we take sine of an angle and we take cosine of an angle. If I ask you to take the derivative of sine of some function, well, it's the derivative of sine is cosine of the same function. I'm not kidding around when I say whatever's in parentheses remains unchanged. Notice that remains unchanged. And the chain rule is that we're going to take the derivative of whatever's in parentheses and tag it on in the end. Similarly, the derivative of cosine of some function, we take cosine of the angle. And when this angle here is a function, well, the derivative of cosine is negative sine. I'm not joking again. Whatever is in that parentheses remains unchanged. What's the chain rule? We tag on the derivative of whatever's in parentheses at the end. So I'm just going to write that. If the function is f, then its derivative is f prime. We saw that in that previous example. So if our equation is y equals sine of 8x minus 1, y prime is, well, I say here, that's what's going to remain unchanged. The derivative of sine is cosine of whatever times the derivative of whatever's in parentheses, 8x minus 1 times 8. So our derivative is 8 cosine of 8x minus 1. Of course, if you want to do it with the u's and dy dx is equal to dy du times du dx, what this would be u. You could set it up like that. Notice as soon as I see this, I start thinking chain rule because this is not one single variable, usually just x. So y prime is equal to derivative of cosine. Well, that's negative sine of whatever times the derivative of whatever's in parentheses. Whatever's in parentheses remains unchanged, and the derivative of this, using your power rule, is negative 2x. To give us negative times negative is positive 2x sine of 9 minus x squared. Resist the urge to change the angle. We take sine of an angle by distributing that out. Bring whatever's there to the front. And there is our answer. There's our derivative. the argument of our cosine here is not just x. So I could say let u equal square root of x, or I could sort of just feel my way along like this, cosine of x to the 1/2. Why do I do that? Because I know I'm going to have to take derivative of that. So our derivative here is -5. Remember, those constants just come along for the ride. The derivative of cosine is negative sine of whatever's in parentheses, and the chain rule says take the derivative of whatever's in parentheses. So this is x to the 1/2, whose derivative is 1/2 x to the -1/2. So we get negative times negative is positive 5 sine, this stays unchanged, square root of x, divided by, well, 1/2. The 2 from that 1/2 goes into the denominator. That negative exponent says, put me down below, and 1/2 is the square root. So we'll have this. Now, this is the argument of sine. I know it would seem like you'd want to cancel those, but don't. And there is our beautiful answer. Of course, when we see this parentheses here, we're thinking, oh, we got to use the chain rule. Y prime is the derivative of cosine is negative sine. So this is the opposite, or -1 times negative sine of whatever times the derivative of whatever's in parentheses. Well, this is 8x squared minus 9x, remains unchanged. The derivative of this, of course, using the power rule, is 16x minus 9. To give us, well, negative times negative is a positive. 16x minus 9, notice I bring that to the front, sine of 8x squared minus 9x. And we can just leave it like that. If I gave you this and I said y equals cosine of x, what's its derivative? Of course, you'd say negative sine x. Now, the only thing is that 5 causes us to use the chain rule. Y prime is derivative of cosine is negative sine of whatever times we're going to chain it up and take the derivative of whatever's in that parentheses. Whatever's in the parentheses remains unchanged. The derivative of whatever in the parentheses is 5. So we get -5 sine of 5x for our derivative. If you're given y equals 4 sine x squared, notice this is not just a single variable like x, it's x squared, so we're going to have to use the chain rule. Y prime, or dy dx, is going to equal, well, the 4 just comes along for the ride. The derivative of sine is cosine of whatever. Here's the chain rule. Whatever that is in parentheses, we're going to take the derivative of that. So x squared, its derivative, of course, is 2x. To give us, I'm going to meet these together, or get these kids together. 8x cosine of x squared is our derivative there.